We're going to spend 2 days on this unit. So we'll get the unit circle, and then we'll move on from the unit circle, and we'll start defining the trig functions and show you how to use the unit circle to get values for your trig functions. The reason why we use the unit circle, unit just means that the radius is 1. We use the unit circle instead of using, a radius of 5 or anything else because it makes your calculations easy. Because using the special right triangles from last time, we figured out that it doesn't matter how big it is, since trig relies on ratios, the size doesn't matter. So just to make our calculations easier, we use a radius of 1. Because we could use a radius of 10 and all of our values would come out to be the same. So that's why we use the unit circle. All right, so let's start going through this. Now let's get some of these that we already know and that are easy. So let's start here. This is going to be 0 degrees, 0 radians. It is also 360 degrees, or 2 pi radians. And what is the corresponding ordered pair? Our radius is 1, so if I go out 1, 1, 0. We're labeling the ordered pair for each of these dots. You'll see why when we define our trig functions. Okay, so let's come up here. This is the next easiest one. So what are the degree and radian values up here? Okay, what's the order pair? 0, 1. Okay, and to the left? And pi. Okay, and the ordered pair would be what? Negative 1, 0. Okay, the bottom one, usually you have to think about it a little bit because it's not... Okay, 270. And 3 pi over 2. Okay, those are your easy ones. Okay, let me give you these next angles. Okay, the ones that we are concerned about are 30 degrees, (45 degrees), and 60 degrees. Okay, we could do the conversions to get the radians, but let me just go ahead and tell you the radians also. The radian measurement for 30 degrees is pi over 6. And it's kind of funny. 30 goes with 6. 60 goes with 3. (45) is half of 2. So half of a half is a fourth. So 45 degrees is pi over 4. Okay, so let's just fully develop this quadrant, and then I'll show you how to get the rest of the quadrants. Okay, so move this down so we have some white space here. Okay, so let's get this ordered pair here. It's really not that difficult. Okay, so we have 30 degrees going up here. What kind of triangle is that? 30, 60, 90. Now, since this is a unit circle, I know that my radius is 1. Now, since this is a 30, 60, 90 triangle, how much is this value here? 1/2. Because remember from last time, this would be my 2n side. This would be my n side. This would be my n radical 3 side. So then what would this side here be? 1/2 square root of 3. Now I'm going to write it a little bit differently just so it doesn't take up so much space. I'm going to write it as square root of 3 over 2. That's still 1/2 square root of 3. Okay, so now I want the ordered pair for this spot right here. Remember, this is on a coordinate plane, so sideways values are x's, up and down are y's. So what's my ordered pair? How far over did I go? How far up did I go? So my ordered pair right here is radical 3 over 2, 1/2. Now, the one for 60 degrees is pretty much the exact same thing. The only difference is I'm standing up instead of laying down. But my values are just kind of reversed here, right? This would be the 1/2. This would be the radical 3 over 2. So what's my ordered pair for 60 degrees? So the way I kind of always remember it is 60 degrees goes, or 30 degrees goes out farther than 60 degrees, and square root of 3 is bigger than 1, so that means the x value has to be the bigger one. So 30 degrees is radical 3 over 2, 1/2. 60 degrees is 1/2 radical 3 over 2, or you can just memorize it. For this, because which one goes sideways? Because x value is sideways. Okay, 45 is going to be, nope. That would be really nice, wouldn't it? The thing about 1/1 is 1/1 would be out here. But with 45 degrees, it's the radius that's 1. Well, that's the side that is the n radical 2 side. So what would I multiply by radical 2 to get 1? So that's the question, is what would I multiply by radical 2 to get 1? Well, 1 over square root of 2. But I need that in simplified form. So the simplified form of that would be radical 2 over 2. Okay, so this part here is definitely what you need to memorize. You don't have to memorize where you got it from. I'm never going to ask you where they came from. I wanted you to see where they came from because mathematically it's a good thing to see. It's a good thing to know. But you're not going to be tested on it. If you forget, and yes, it'd be a good thing that you could muddle through and figure out again, but nothing you're going to be tested on. Again, what you're going to be quizzed on is, can you reproduce that? What you're going to have to be able to do on tests and stuff is be able to recall this from memory to be able to use. As your eyes get big. Okay, so now we have to figure out the rest of it. Okay, let's start with the angles, because the angles are the easy part. And it's actually a lot easier to get the radians than the degrees. Because the radians, let me start with the pi over 4, because the pi over 4 is the easiest. All you're doing is you're counting by fractions. So, the pi over 4s go here, correct? They're each of the middle lines. So this is 1/4. So 2/4 would be 1/2, right? So then this would be 3/4. So then this would be 4/4. Well, that's just 1. This would be 5/4. 6/4 is 3/2. 7/4. I almost wrote 8s there, sorry. And then 8/4. Okay, so let's do that with sixths. Or not sixths, but thirds, sorry, thirds. So the thirds are up here. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. And then with sixes, now sixes, most of them reduce down. So I have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. Now, instead of counting all the way rest of the way around, this is going to be 1/6 less than 2, correct? So 2 is going to be 12/6. So what's 1 less than that? 11/6. So see, I have one more than 0, one less than 1, one more than 1, and one less than 2. So the pi's are actually really easy because fractions are not that hard. The degrees are the ones I find difficult, mainly because I don't like adding all the bigger numbers. The 45s, so 45, 90, 135, 180, 180 plus 45 is 225. Then you have 270. 270 plus 45 is 335. Wait. 315. See? And then 360. Adding the 60s, you have 60, 120, 180, 240, 300, and then 360. Now again, with the 30s, it's easier just to do a little bit of subtraction. 30 less than 150, or 30 less than 180 would be 150. 30 more than 180 and 30 less than 360. So there's all your angles. Again, memorizing the whole thing with all the angles is a little ridiculous. Once you have what your basic angles are, it's easier just to calculate the rest of them. Okay, nice thing about the ordered pairs. Notice, your ordered pairs are all at the same point, just different quadrants. So the only things that change in your ordered pairs are the signs. So, what do you think this ordered pair over here is? Nope. Nope, not 1/2. Negative square root of 3 over 2, 1/2. For all pi over 6's, it's going to be the exact same order pair. You just change signs. So since this is the second quadrant, in the second quadrant, the x values are negative, the y values are positive. So down here, what's the pi over 6 order pair going to be? Yeah, so it's going to be negative and a negative. So at this point, I mean, you can take any of your ordered pairs and do that with them. So this one's going to be negative radical 2 over 2, radical 2 over 2. And here, it's going to be negatives and negatives. So go through and fill in your ordered pairs. Remember, you don't change the order of any of them, you're just changing signs. And there's your full circle. Yep. Both. Yep. Wherever you do it, I want to see that everything on there except for what I did for that triangle work on the outside. So this is what I'm looking for. Alright, we're going to spend a little bit of time. I'm going to show you how to actually use it because, I mean, it's great, that's there. Why? So I'm going to show you how to use it and then, okay. And then that'll be it. And then I split it up, not so much that we need it split up, but more of I split it between 2 days, so tomorrow we can go back through this again. I'm not going to spend as much time going through it as we did today, just so we can review it again tomorrow and review how to use it again tomorrow. And then Wednesday we'll move on and do another lesson. Then Thursday, I'll just give you a blank one of these, have you do it. The rest of the time will be work time. And then Friday, we'll have a real quiz. Like a full-blown quiz over everything you've done so far. That'll be Friday. We'll drop 2 quizzes over the semester, like we did last time. All right, am I good to move it? Oh. All right, so let's define our trig values. Now, I told you guys yesterday that we'll end up having 3 different definitions for your trig values. So we defined your trig values on a triangle. So like that was sine is opposite over hypotenuse. So now we have a new definition for sine. Our definition for sine is going to use the triangle definition, but it's going to be different. So, let's go back in here. So, whenever I use sine is opposite over hypotenuse, right? Okay. Well, whenever I do opposite, think of this as a triangle again, and I'll mess mine up, but here, let me draw it here. So I have this line out here to this ordered pair. Yeah, you can do whatever. I have no problem with that. I mean, I don't check your guys' notes or anything, so. Okay, I'm using this one as an example. So this would be sine of 30 degrees. I'll just use this one to get your trig functions. Okay, sine is opposite of hypotenuse, right? So if I was doing sine of 30 degrees, opposite would be 1/2. Hypotenuse would be 1. So that would be 1/2, correct? So if I generalize that, 1/2 is the same thing as my y value. So whenever I'm doing trig of my unit circle, sine is always equal to my y value. Because my hypotenuse is always equal to 1. So my hypotenuse is taken out of the equation. My y value is always my opposite value. So all I need to do is grab my y value. So again, that comes from my triangle. I'm not really creating a new definition for sine. I'm using what it already is, but I'm simplifying it on my unit circle. So what would the definition for cosine be? X. Right, cosine would be adjacent over hypotenuse. Well, the adjacent side is my x value. And again, hypotenuse doesn't matter, so cosine is defined as x. So what's tangent going to be? There's no z. Y over x. Okay, so this is how we use our unit circle to get some of these values. These are very common values, so this is how we use it. So if I want cosine of 5 pi over 4, I look on my unit circle, I find 5 pi over 4. Cosine is the x value, so what's the x value at 5 pi over 4? There's my answer. That's all you have to do. Okay, cosine of 5 pi over 4. I have my unit circle, I find 5 pi over 4, which is right here. Cosine I just defined as the x value. What's the x value of the ordered pair? Yeah. Eventually, no. To begin with, yes. On Friday, you're going to be allowed to use your unit circle.
What is this for? Why?
This is trig.
Why does that equal x?
Because cosine is adjacent. Adjacent is the x value. Okay, what's sine of negative pi over 3? What? Yes. Quiz on Friday is going to be normal quiz. It's going to be over everything we've done. Okay, what's sine of negative pi over 3? No.
It would be something.
Or wait, I'm sorry, yes. You're right. I'm sorry. Sine of negative pi over 3. I know, I created a foul. I told Teddy he was wrong. I know. Okay, negative goes in the other direction, correct? So I go negative pi over 3, which would be right here. Sine is a y value. So the y value right there is negative square root of 3 over 2. Okay, that's why we do multiple examples. Tangent of 4 pi over 3.
Well, yeah. What if the 2 equals 1 so, square root of 3.
Square root of 3. You have to take the y value divided by the x value. So whenever we divide fractions, first, yes, the negatives will cancel out. Whenever you divide by a fraction, that means you multiply by the reciprocal. So my 2's would cancel out, so I just get square root of 3.